Assalamualaikum and good morning to all. Today I will be discussing two innovative systems that address critical urban challenges. For example, the mall parking management system and the bicycle warning system sensor. In a world where their pace of life is accelerating, technology has become essential in solving daily challenges. And this system exemplify how automation and real-time processing can enhance efficiency and safety. First, the mall parking management system focuses on reducing congestion and efficiency in shopping mall parking lots. By dynamically monitoring parking space availability, the system guides users to vacant spots, saving times and minimizing traffic. It leverages Python frameworks like Flash or Rejago for a user-friendly interface, while libraries like OpenCV and TensorFlow enable machine learning and image processing for parking detection. Real-time data is stored and retrieved using Python database connectivity tools. For the bicycle warning system sensor, on the other hand, addresses the growing concern for cyclist safety in urban areas. Equipped with sensors, it detects obstacle or vehicle near a bicycle and provides real-time visual or auditory alerts, reducing the risk of accidents. Python is instrumental here, integrating with hardware like Raspberry Pi and processing sensor data using libraries such as NumPy, Pandas, and scikit-learn. This ensures a proactive safety approach for cyclists. Both systems highlight Python's versatility, from web development and image processing to hardware integration and machine learning. Challenges like optimizing real-time processing and ensuring seamless hardware to software integration will overcome through iterative testing and careful library selection. The results are scalable, efficient systems that address pressing urban needs while demonstrating Python's potential for real-world applications. In conclusion, the mall parking management system and bicycle warning system sensor are practical, scalable solution to urban infrastructure challenges. They reflect how technology can drive innovation and improve daily life.
Hi, my name is Nur Sharina Shafika. My matrix number is CD 240049. I will talk about problem statement in my project. This slide highlights two significant problems: more parking management system and the growing need for a bicycle warning system sensor, both of which focus on improving urban efficiency and safety. For more parking, the challenges begin with overcrowding and inefficient use of space. Many parking lots are poorly optimized, leading to wasted spaces and drivers spending excessive time searching for available spots. This creates customer frustration and results in a lot of wasted time, especially during peak hours. Moreover, there is often no real-time monitoring or guidance system in place to direct drivers to vacant slots efficiently. For mall operators, this lack of real-time data makes it difficult to manage operations effectively, further contributing to operational inefficiencies. This issue highlights the need for a better parking management system that can monitor space usage in real time and guide drivers seamlessly to available spots, creating a smoother experience for everyone. On the other hand, the bicycle warning system sensor addresses an entirely different but equally important challenge: ensuring cyclist safety. With the increasing number of cyclists on roads, the risk of accidents has risen. Cyclists often encounter hazards such as vehicles, pedestrians, or other cyclists, and at high speeds or in crowded areas. These hazards can be hard to detect in time. There is currently no effective real-time warning system available to alert cyclists to nearby dangers. This gap leaves cyclists vulnerable, especially in urban environments where distraction and obstacles are frequent. A warning system sensor would provide cyclists with a real-time alerts, allowing them to react quickly and avoid potential accidents, making cycling a much safer activity for everyone. In summary that I get from my problem statement, both problems highlight the urgent need for innovative solution. A modern parking management system can reduce congestion, save time and improve mall operations, while a bicycle warning system can enhance safety and reduce accidents. By addressing this issue, we can create systems that promote convenience, efficiency, and safety in everyday life. Thank you.
Okay, so for solution 1, implementing a comprehensive smart parking system in a mall includes several key features that enhance efficiency and customer satisfaction. Sensor installed in a parking spot detect real-time availability, transmitting this data to a digital board and mobile app to guide customer directly to vacant spaces. Dynamic pricing status based on a demand and designation, for example, short-term VIP valet parking, maximize revenue while the offering teleparking options. Mobile apps allow users to pre-book spaces, further reducing the time spent searching for parking. Extremely enter and exit processes are achieved through automatic payment system such as license plate recognition or contactless payments, minimizing consideration. This intelligent approach improves parking efficiency, extends customer convenience, and boosts operational effectiveness for mall management. For solution 2, a bicycle warming sensor system with advanced detection and alert capabilities ensures excellent safety for cyclists in dynamic environments. Installing ultrasonic or LiDAR sensor provides 360-degree coverage to identify nearby vehicles, pedestrians, or other cyclists with precision. This detection system is complemented by a multi-modal alert mechanism that uses visual LED audio vibration signal to notify the cyclist for imitating the hazard, ensuring quick and intuitive reaction. Pairing the system with the mobile app or integrate display enable real-timing mapping of obstacles and offer detailed collision risk analysis, giving a rider comprehensive awareness of surroundings. This integrated approach reduces accident risk and promotes safer, more confident cycling.
From this slide presentation, we will present about the two flowchart that we have made based on the problem that we have chosen for our project. For example, mall parking management system and bicycle warning system sensor. This flowchart is made to better understand the way of work that we need to do. At the same time, being able to know the work path from the beginning of the work to the end. Regarding Python, in producing coding, the flowchart shows the work path from start to finish to solve selected problem more easily in the work of producing coding using a Python.
Hello, my name is Shashin and I would like to explain about how this code works step by step. Firstly, let me talk about what is this program. This is a mall parking management system and it manages 20 parking slots and it allows vehicle entry, assigns a free slot, vehicle exit, it freezes the slot and calculates payment and status display. It shows which slots are free or occupied. Secondly, I would like to talk about the key components of this parking slots class. Firstly, it represents each parking slot and it tracks each parking slots whether it's empty or not, and it manages the entire parking system tracks. So it will show whether it's free or occupied, and it will show which vehicle is currently parked there. And it handles, we can find which free slots and we can log in entry and exit details, and also we can calculate charges for parking. Let's say we enter the mall for 1.5 hours, so we can calculate how much it costs for 1.5 hours. So I've attached the example in the slide. And now I would like to talk about how it works. The system starts with 20 free parking slots. The list stores information about parked vehicles. Step 2, vehicle entry. A vehicle enters the program, finds a free slot, blocks license plate, vehicle type, entry time, and marks the slot as occupied. If no free slots are available, it shows a no free slots message. Thirdly, vehicle exit. A vehicle exit, the program matches the license plate with parked vehicles. It calculates the parking duration and charges for it. For example, it's 2 ringgit per hour, and it marks the slot as free if it is not occupied. If the vehicle is not found, it shows an error message in your phone. And step 4 is display parking status. So it will show which slots are occupied or free. Sorry, I'm having flu now. And now I'd like to talk about menu options. When the program runs, users can say whether a vehicle entry, so they enter license plate and vehicle type, vehicle exit, enter license plate to exit, display parking status, we can view all slots whether it's occupied or not, and lastly exit program, quit the system. Now I'd like to give you some example. So user chooses vehicle entry and the number plate, let's say it's ABC123, and type car, system assigns slot 1 and lock entry time. Display status, user chooses display parking status, system shows slot 1 occupied, slot 2 to 20 it's free. So as you can see, if the slot 1 is occupied, then rest of the thing automatically shows free, and then the one that occupied will automatically turn it occupied. The vehicle exit, so if, let's say the user chooses vehicle exit and enter license plate, the slot 1 which is occupied before will be free now, and we can calculate the Now I'd like to talk about the other project that we did. So this program is a simulation of bicycle safety monitoring system using various virtual sensors, and it includes 5 key sensors: proximity sensors, speed sensor, ambient light sensor, road surface sensor, and blind spot detection sensor. Proximity sensor monitor the front and rear of the bicycle and generating random distance from 1 to 100 meters, and if an obstacle is detected within 10 meters, a warning is displayed. Secondly, speed sensor. This stimulates the bicycle speed, generating a random value between 0 to 50 km per hour. If the speed exceeds 30 km per hour, a high speed warning is shown. And the third one is ambient light sensor. This checks the surrounding light level from 0 to 100%, and if the lighting level drops below 20%, it suggests turning on light for safety. And the fourth one is road surface sensor. This detects road conditions, randomly selecting between smooth, bumpy, and slippery. If the surface isn't smooth, a warning advises the rider to slow down, and it's so on. So if it's slippery, you slow down. So it's bumpy, we need to be careful. It's like that. And the fifth one is blind spot detection. It monitors the left and right side of the bicycle, because most of the time we don't know what is happening right side and left side when we riding bicycles, so it will be helpful. so it will be helpful to detect in our blind spot, and it raises an alert as well. The program's main function is to run all the sensors in 3 rounds. Each round collects sensor data, print a warning when hazards are detected, and provides a summary of readings. For instance, it might warn about obstacles, high speed, poor lighting, slippery roads, or objects in blind spot. To start the program, we need to ensure the condition is correctly written. This simulation demonstrates how much a system could enhance bicycle safety by actively monitoring potential risk and alerting the rider. So later I will attach a demo for both the parking and bicycle system, so we can see how the code run and everything. So I will attach the video later after this presentation. Thank you.
Hello, my name is Munish Mittanraj. My matrix number is CD240305. Today I'm going to talk about the formula and equations of the bicycle warning sensor system. First, the proximity sensor check. The program measures proximity to obstacles, front and rear, and generates warning the distance is less than 10 meters. As for the formula, proximity distance meter, which is equals to randomly generated value in the range of 1100. If the distance meter less than 10, then the warning obstacle detected at the distance mean front and rear. Second, the speed sensor check. The program simulates the speed reading and generates warning if any speed exceeds 30 km per hour. Formula: speed km per hour, randomly generated value in the range 10-40. If the speed km per hour more than 30, then the warning high speed detected, speed km per hour. And the third one would be the road surface condition check. The program the surface and generates warning if the surface condition is not smooth. Formula: road surface conditions, random choice from smooth, bumpy, slippery. If the road surface conditions are not smooth, then the warning road is condition, please be cautious. Next is the calculation for the second problem, which is the mall parking penetration system. So first is the duration calculation. The duration is calculated is the difference between the entry time and the exit time. The formula for the duration is minutes, duration minute, exit time minus entry time, times with total second divided by 60. Here, exit time and entry time are determined objects. Total seconds gives the total difference in seconds, and dividing by 60 converts it into 10 minutes. The second calculation is the payment calculation. The payment is calculated based on the parking duration. The rate is defined as RM2 per hour. The formula for payment is payment duration per minute divided by 60 rate per hour. In this case, rate per hour equals to RM2. The duration is converted from minutes to hours by dividing by 60. Example, if a vehicle is parked for 90 minutes, calculate duration in hours. Duration hour 90 divided by 60 times with 1.5 hour. Calculate the payment. The payment would be 1.5 times with 2.0 equals to RM3 ringgit. This vehicle would be charged RM3 ringgit for the 90 minutes of parking.
In conclusion, install sensor in parking spot and display available spaces on digital boards and mobile apps. Implement dynamic pricing and zone designation for short-term VIP for valid parking. Enable pre-book through the mobile app and streamline entry or exit with the automate payment system. Provide a centrally dashboard for real-time monitoring, predictive analytics, and maintenance alert. And a bicycle warning sensor system with a variable real-time hazard detection mechanism leverage technology like proximity sensor, machine learning, and GPS tracking on enhance cyclist safety. Proximity sensor detect nearby obstacles, vehicle, or pedestrian, while a machine learning analyzes the data to evaluate collision risks and issue timely alert through a visual, auditory, or haptic signal. GPS tracking integral located base hazard awareness, warning cyclists about a high risk zone such as busy intersection or sharp turns. This system reduces accidents risk by providing cyclists with actionable real-time information, enabling them to react properly and navigate safely in a dynamic environment.